So what if I asked you to FOIL, to multiply, to distribute, and kind of expand these two binomials? What would we get? Well, let's find out. Looks like you would get an x cubed. What else? You would get a 4x. You would continue to multiply, distribute, or FOIL everything, and we're going to get a 3x squared. And it looks like the last one, what color do I still have left here? Green would be 3 times 4, it should be 12. So x cubed plus 3x squared plus 4x plus 12. What if I wanted to factor that expression? What if I wanted to factor that? Well, shouldn't it turn back into these two binomials? It should. The question really is how? How could you take these 4 terms and turn them back into these 2 binomials? Well, we would need a new factoring technique, and it's called factoring by grouping. Factoring by grouping, now if you flip your foldable paper over from yesterday, I'm going to encourage you to just kind of put this on the top side. It doesn't really fit so nicely into like 4 sort of sections, so why don't we just kind of take the top side of your paper and we'll use this for some grouping examples today. So what is factoring by grouping? Well, I'm going to give you a couple thoughts which maybe you want to jot down sort of like in the middle here, and then we'll do it for some examples. So it's called grouping for a reason. Again, you might want to jot these down kind of in the middle if you want. You see, you're always going to create 2 groups. You'll find out that that really means putting parentheses around some of the terms. Next, you're going to factor. You're going to actually factor out a GCF. And when you do that, you're going to see that what is left, what is remaining, is actually going to be equal. You'll see it'll be equal to what is also remaining from the other group. And finally, you'll write the factors. It's actually not very hard. It's just a new factoring strategy. And it's a factoring strategy that is used for, well, maybe like this big expression that we started with, x cubed plus 3x squared plus 4x plus 12. Let's just kind of call this simple. Basically, a couple problems we're going to do here. There's really nothing that's strangely different. And so let me show you what I mean by create 2 groups. Create 2 groups. Basically, put parentheses around the first 2 and the last 2 terms. Now, each one of those groups has a GCF that I can factor out. I can factor something out of x cubed and 3x squared. That's right, it would be an x squared. That would basically be the greatest amount of x that is common to x cubed and 3x squared. So again, I took out a GCF. But I can also take a GCF out of this group. Well, that GCF would be a 3. And look what you're left with. Oops, my fault, not 3. Let's try 4. Okay, you're factoring out a 4. And look what you're left with. That's right, you're left with x plus 3. Now, did you see here what I said, that what is remaining is going to be equal? X plus 3, x plus 3. Yep, that's the way it's supposed to work. Whatever's remaining is going to be equal, so that you can write your 2 factors. Now, when you write your 2 factors, what you're going to do is you're going to use the GCFs, and they will become one of your factors. Notice that I took x squared and the plus 4 and I put them together. The other factor is going to be this thing that is, well, that was equal, that was remaining, the x plus 3. But I only have to write it one time. I only have to write it one time so that I end up with what I started with. Now, we already did this at the beginning of the lesson, but remember, if if you multiply these things together, you're going to get x cubed, you're going to get 3x squared, you're going to get 4x, and you're going to get 12. You're going to get what we started with, which is why we correctly have the factors. Again, the factors being x squared plus 4 and x plus 3. Let's try another one. Can you kind of squeeze it into one of these sort of spaces up here? I think we're going to end up doing about 4 problems here. So, we can put 2 problems kind of in this space, and eventually we'll put 2 problems over here. So let's try another one. Can you fit another example kind of in this left-hand side? We're going to end up then doing 2 more examples that probably you can kind of put over here on this right-hand side. But basically, we're going to do about 4 problems. Do you have enough space to put 4 problems up here? How about this problem, x cubed minus x squared minus 9x plus 9. X cubed minus x squared, I want that to be a minus 9x plus 9. So what do we do first? We're going to have to make 2 groups. Now when you make your 2 groups, what you want to do is you want to group the negative with the 9. You want to group the negative with the 9x. Not the negative kind of being like floating out there, because that changes the problem. So I want my negative to be just with the 9x. Now what we want to do is we want to take out a GCF. How much x can I take out? You always want to take out the most amount of x, the greatest, that's common. Now be careful, you're not left with 0, but you're left with 1 when you take x squared off of x squared. Now sometimes kids will ask, well, what am I going to take out of here? Am I going to take out a 9 or a negative 9? Well, take a look. You want it to be a negative 9. The reason is because you want to have a minus 1 left here. Now negative 9 times minus 1 is going to go back to the plus 9. But again, why do I want a minus 1? Well, because look, I have it over here also. You always want these remaining factors to be equal. You want them to be the same. So I take my x squared minus 9 and I make that a factor, and then I take my x minus 1. I know it's written there twice, but you only have to write it once, and I make that my other factor. X squared minus 9 and x minus 1. Now there's something kind of interesting about this problem, that is that x squared minus 9 just so happens to be able to be factored again. You see, x squared minus 9 is called a difference of squares. Now a difference of squares is always going to factor into a plus and a minus. Notice the plus and the minus of 3. That's because, of course, 3 and negative 3 is where the minus 9 came from. And what you're seeing here is that I was able to further factor. I was able to split it a little bit more. Grouping. Are you ready to try one? See if you can create 2 groups, factor out some GCFs. Hopefully you're left with the same thing, and then you can write your final answer. Sometimes kids ask, do I always, group the first 2 and the last 2? Well, the problems that we do, yes. Could we have grouped differently? Perhaps. We could have rearranged the problem, especially if after we take out a GCF, we discover that we don't get the same thing. But when I take out the GCF, when I take out the x squared, I discover that I get x minus 8. And then when you take out a 4, you discover that you get x minus 8. So I don't need to change the order of anything because I'm left with the same thing. And that's, of course, the way this is supposed to work. And when you see that, you're able to write your final factors. Now, your final factors are always going to use the GCFs in one group, and then the item that was the same, which is really another factor, as your other group. And that's it. That's it until we get to a problem that maybe it's just kind of a little special. Maybe it requires a little bit of some extra thinking. We'll just sort of call it a plus. You know what? Yeah, we'll just call it plus, meaning that there's some extra thinking. I don't want you to think that it means necessarily that there's a plus sign. Now, if I hadn't said that to you, what do you think here? First of all, yeah, we've kind of got some big numbers. We got 4x to the fifth, minus 25x to the third, 4x squared minus 25. But first of all, do you realize that we have 4 terms? That's usually the giveaway that you're going to want to use factoring. If there's, factoring by grouping. So when there's 4 terms, you can kind of do the grouping thing, where you basically group the first 2 and last 2 terms. And then you can do the GCF thing. Now the GCF, at least the highest number, appears that it's only going to be an x, but an x to the third looks like that leaves us with a 4x squared and a minus 25. How about this one over here? What do you think about GCFs? Yeah, it doesn't really seem like there is a GCF, does there? Okay, well, never fear. All that means is that the best number I can take out would be the number 1. Now, the reason that I want to write the number 1 is so basically I still have a GCF to circle. To circle that specifically becomes my first group. Again, if there's no GCF, then the best I can do is think of it as the number 1. But, that allows us to follow the same strategy. It allows us to be able to create our 2 groups. Now, the thing that is special about this problem, maybe the little plus piece, is just like we did previously, 4x squared minus 25 actually can be broken down again. It can be broken down into a 2x and a 2x, as well as a plus 5 and a minus 5. You see, 4x squared minus 25 is called a difference of squares. And a difference of squares can be split into its factors, which are 2x plus 5 and 2x minus 5. Sometimes kids will say, how do I know? How do I know if I have to do this extra step? Well, basically from experience. You just get good and you start to recognize when you can further factor. How many problems have we done? Is this the 5th one? I think I said we were going to do 4. Do you still have space for a 5th problem? It probably wouldn't be the worst thing to try this one. Again, it just kind of looks a little bit sort of a little scary. But if you follow the grouping method, you find out that it's not really that bad. Okay, now again, you just want to take out the GCF. That's the most amount of x that's common to both of those. I feel like that x squared is the highest amount of x, and all that really does is just kind of skim these down a little bit. Now, what GCF do I want to take out of this other group? It kind of seems like there is no number. Like there's no GCF for 64 and x squared. So should I take out a 1? Well, almost. You see, I actually want to take out a negative 1 because I want this minus sign right here. I want to have 64 minus x squared. Why does that have to be a minus sign? Well, think about it. I have a minus sign here. I need another minus sign here so that I end up with a plus sign in my original equation. So 64 minus x squared looks the same as this 64 minus x squared, which is good. It's good, good, good. That means I can create my two factors. Now, it just so happens that both these factors can be split up again. It just so happens that they are difference of squares. What's a difference of squares? Well, it's when you have perfect squares and a minus sign, which you can split into a plus and minus sign. Same thing's happening here. 64 is a perfect square, so I can break it down into 8 and 8. And then x squared can be thought of as a plus and a minus of x. And so this problem, I guess, had a real plus plus because I had this extra step for both of them. If you were in class, you would do this problem as a little exit ticket. You want to do the same thing that your classmates are doing. So see if you can use the grouping method one more time here on your own to factor 3x cubed minus 27x minus 2x squared plus 18. Okay, treat this like a little exit ticket. Basically, it's a problem you should try to do. If we were in class, I would tell you if you were doing it correctly. Since we don't have the option of me telling you if you're doing it correctly, then the best thing I can do here is show you, of course, after you try it. So you want to pause the video. And now we're ready to take out a GCF. Now, did you realize that 3 is the highest number that is common with 3 and 27? And so it goes with x. You basically want to take out a 3x so that you're left with x squared minus 9. How about over here? Okay, do I want to take out a 2 or do I want to take out a negative 2? You see, I want to take out a negative 2 because I want to be left with x squared minus 9. Again, the two negatives that you get here are going to turn back into 18. Okay, so I take out a negative 2. Now I see the x squared minus 9s are the same. I know that I'm definitely on the right track. I can take my GCFs and record them as a factor. I can take my x squared minus 9 and record it as a factor. Okay, now what we did here is really good. But if I want to be really, really good, I would recognize that x squared minus 9 can break down one more time. It's a difference of squares. I can split it up with x and x and a plus 3 and a minus 3. And so sometimes problems have additional factoring after you do the primary grouping. All right, so your homework is a homework helper or a slip of paper that I hand out in class, but you can grab that digital copy off the calendar.